Okay, folks, you should be extremely grateful in your hearts that you have the opportunity to hear me today, even if you can't see me directly. It's going to be a fantastic day. Oh, isn't it though? So, to start off with here, you see a periodic table on the board, but there are no names or numbers of any kind. All you see is the words groups and periods. Huh, I wonder what those mean. Let's take a look. It appears that there are arrows on the board, and the arrows next to where it says periods are pointing to the right. Those must be rows. So periods are rows of the table. Pretty complicated. Also, I assume you can see some other arrows. They're pointing down, aren't they? And those are the groups. Isn't that nice how I underline that? So those are the groups of the table, and they are the vertical columns. So we have rows and we have columns. We have periods and we have groups. What's the meaning of all of these? Well, you'll notice that the periods on the table are numbered. We have 1, 2, 3, 4, 5, 6, and 7. So there are 7 periods across the table. And your tables that you should have out right now with your comp books, I assume, those tables have also the periods numbered 1 through 7. Now, your table that I gave you has Roman numerals as the group headings. So not all tables have the groups listed the same. The table on your left on the wall has the group numbers 1 through 18. Some tables are listed like that. I believe the one in your textbook is also listed as 1 through 18, whereas the one on the wall to your right has Roman numerals. So what do we use? I suppose numbers 1 through 18 would be a better way to describe groups, so that they each have a number. So again, we have 1, 2, and we hop across to here real quickly: 13, 14, 15, 16. Uh-oh. Are we missing a group? We seem to be missing a group. Can you hear the silence? This table is incorrect. This is awful. This is a tragedy. Whoever developed this table doesn't know what they're doing. Let's just see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh. This table isn't correct at all. Except that it has 7 periods. This is a tragedy. We don't have the right number of blocks. Whatever will we do? Well, I guess we'll take those off. Because all we really care about is that the group numbers can be seen at the top of each column. Now, we've already talked a little bit about what those groups have in common. And if you look at your periodic tables, and you'll look at the very first group, number 1, you'll see the last electron number as a 1 on every one of those elements. And again, we've already had this discussion. Second column, or second group, the same is true. 2 is the last electron number. That's the same as you jump across the transition area, this being the transition area. As you jump across the transition area to the far right side of the table, those group numbers continue to increase, but each of those columns, beginning with boron here, has a 3 as its last electron number as you head down with the group. So here's what happened when the table was being set up. We have rows, as you can see, but as the rows were being built from top to bottom, they realized that vertically they could line up the elements so that their valence numbers were equal in each of the groups. So groups then have equal valence numbers. That might be something worth writing down. So the groups on the table have equal valence numbers. And they progress from 1 on the left up to 8 on the far right. And so that, my physical science friends, is why we jump. If you look at the second row here, second row on the table, second period of the table, we jump from 1 to 2 here, and we go all the way across here to the boron group, group number 13 on your table, before we get to 3. And why did they skip all of these spaces across here? All of these spaces were skipped so that boron could be in the same group as the other elements that have 3 valence electrons. One other thing about groups is that they are also sometimes called families. And families have a couple of things that are interesting. One of which, they have the same valence number, which we just discovered. And they have similar characteristics. Might help if I could spell similar correctly. Oh boy, this is a bad day. It's a good thing I'm not here. I know you're laughing. So similar characteristics and the same valence number. Now this other little table here is getting in my way here. It's cramping my style. So let me move that down some here. Or maybe it's not going to move down. Let's see. Technical difficulties. Oh yeah, we got it. So, families are groups, and they have numbers 1 through 18. That is how the table is set up. And again, the periods on the table, as we've already mentioned, the periods on the table are arranged as horizontal rows so that the vertical columns can have the same valence numbers. And again, we've seen that as well. Same valence number down the groups. Well, what else to tell you about the periodic table? There's so much. Are you freaked out still that you're hearing my voice and yet I'm not in the room? This might be a better way to go. I may have to teach like this more often. It's kind of nice. I don't even have to look at you right now. Or am I? Maybe I have set up that webcam. So anyway, we have periods and groups. The major ways in which the table has been arranged. Moving on from that, we have this other periodic table that I'd like us to take a look at. The table also can be split into different categories of materials. If you'll notice here, here on the table, those are metals. There are three main categories of substances on the table. The blues are metals. The purples, or violet, or whatever you might call that, are metalloids. Sometimes also called semi-metals. So we have the metals, the metalloids, and the yellow. What do you suppose the yellow elements are? The non-metals. Notice there seems to be a dividing line on the table. So again, the yellow are the metals, the non-metals. The purple or burgundy or violet, whatever those are the metalloids. And of course then, the blue are the metals. There are many more metals than any other type of substance on the table, as you can see. And in fact, there seems to be a dividing line between the metalloids and at the metalloids, between the metals and non-metals. So what you might want to do on your table, which I think will kind of make things easy for you, and I don't know if you'll be able to see this or not, but you might want to draw a little line here around, because maybe you've seen that jagged stair-stepped line on your table, and maybe you've seen the red line on the one on the wall to your right. But these pinkish violet looking elements, those are the metalloids. So you may want to just kind of lightly with a pencil outline these particular elements on your table. Now, what good will that do? Well, that will obviously tell you which ones are metalloids, but also it will show you that everything on the left of that category are metals, with the exception of hydrogen up in the corner. The only non-metal that is on the left side of the metalloids. So we have the one little lonely non-metal on the left side of the table. The rest are metals. And of course then, everything on the right side of the metalloids are the non-metals. So that is how the table has been set up, with periods as rows, with groups as columns, clearly separating each of the three types of substances: metals, nonmetals, and metalloids. Now, there are certain things, characteristics you could even call them, about each of those three types of substances. You can find those in the book. If you turn to page hang with me here for a moment. Turn to page 155, please, and spend a few minutes looking at the diagram there on page 155 at the top that shows you the three different categories: metals, nonmetals, and semiconductors. They're also called metalloids, semiconductors, or semimetals. So several different ways in which they describe these metalloids. So read, as I said, page 154 and 155, and take a look at the diagram there. You might want to jot some things down about metals, nonmetals, and semiconductors, or metalloids, that would be worth noting. And I'll be back once you're done reading in the text.